right? We use identities to verify other identities, right? By identity, what we mean is when you've got an equation, if we were solving an equation, and in the course of solving the equation, all of the variables canceled, and what you were left with was a true statement, it means it's true for all values of the variable. That's called an identity. Most of the time when we solve equations, we solve and we get one answer or two answers for a quadratic, etc. Those are called conditionals. That vocabulary was at the very first part of the course in the section P4. We rarely use it, right? We rarely say I'm solving a conditional when we solve an equation. But identity is true for all values. So the three that are the Pythagorean identities, those are true no matter what the thetas are. It's always, those relationships always hold. Now, just like we did in math induction, where we would have to show that the left side equals the right side, that's what we're trying to do here. Show that what's on the left is the same as what's on the right. Sometimes that will mean simplify the left. Sometimes that will mean simplify the right. Or maybe it'll mean simplify both sides until they look the same, but make the left side look like the right side, or the left-hand side look like the right-hand side. So just looking at this cosine times secant, does anybody can think of a substitution we could make? Subtract cosine? I don't think so. That's a multiplying between those. Divide by cosine? Okay. Let's say we did that. Divide both sides by cosine. Now we've got secant of theta equals 1 over the cosine of theta. Yeah, and honestly, that is one of our identities, right? That was basically like a definition of the secant. For what? The one we wrote down is why would you put a 1? If 1 times secant is what? Right, you don't write ones for multiplication. I know, but at this level, right, if you do that at the 1, you don't write it down. Okay, just secant theta is 1 over cosine. I mean, at this point, you could like take a step and say, well, I know that 1 over the cosine is the secant, therefore secant equals secant. It does say make the left-hand side look like the right-hand side. Most of the time, that's not exactly how we do it, but what we find when we verify these identities, there's usually more than one way to verify an identity. You know, it makes them hard to grade because you can go all the way around in a different direction, which honestly, what we did there is not what I would have expected to do. I would have expected, let's substitute secant as 1 over cosine here. Then we had cosine times 1 over cosine equals 1, and cancel the cosines. 1 equals 1. But it's the same thing. In the end, you know, we're using the same substitutions. Trevor, give it a rest.